Okay, so what we're going to do now is take a look at how to work with the copy rotation constraints using world space, local space, and pose space. Now, before we can do this, we actually have to understand how do rotations work on a coordinate system. So we have to look at them at the most basic level. Now over here, if you click this, you'll see that we have quaternion, Euler, and axis angle. We're not going to look at this right now. I'm going to talk about this separately. Right now, we're just interested in visually what we are seeing inside the 3D view. So what I want you to do is go ahead and press the 7 key to go to your top view, do Shift C to place the 3D cursor in the center and go ahead and switch to a new layer. Now you're going to do Shift A and add a plane. Now do Shift C to quickly focus in on this object. Now press the Tab key. Click on this vertex, press the Shift key down, click on this vertex and this vertex, do X and delete the vertices. You should only have one vertex left. Go ahead and zoom in a bit, do Shift middle mouse button to pan over here. Now what we're going to do is switch to object mode, click on this red arrow and move this to the right a bit. Now go under File, do Save As, and you're going to save this as Bone Concepts 8.blend. Go ahead and switch to Edit Mode and click on this vertex. Now right now we're looking at our scene from the top orthographic view. So we're going to be talking about the y-axis and the x-axis to understand these fundamental concepts. I'm going to go ahead and zoom in a bit. Now when you press the G key to move this vertex, here you'll notice that we're moving along the x and y axis. These are the only two numbers that are going to change. Of course, if we do the middle mouse button to rotate and click on this blue arrow, we're going to be moving the vertex on the z-axis as well. Do Ctrl Z to undo this and press the 7 key to go to your top view. Now over here, you'll notice that local is selected by default. So the numbers that are being shown over here are showing how far this vertex is away from its origin point, because this vertex belongs to this object. Now when we click on global, press the G key, this vertex is now showing how far it is away from the center of the 3D grid. In both cases, we can only change the location of this vertex along the X, Y, and Z coordinate system. Go ahead and switch to local. So the question here is going to be, why does this vertex need to know how far it is away from the origin point? This is because when you switch to object mode and press the G key to move your object, the vertex must maintain its distance at all times to allow you to move your 3D object, because vertices are what define how your 3D model looks. Now go ahead and switch to edit mode and click on this vertex. Now when we press the Shift key down and click on this X value and change it, we are moving along the X-axis and the Y-axis. When we switch to global, do the same thing. It's along the X and along the Y. So this tells you that when we click on a local, this vertex is actually moving inside an internal local coordinate system that belongs to this object. We can see this by simply clicking on the grease pencil, going to line and drawing a line to represent the y-axis and to represent the x-axis. Press the escape key to get out the grease pencil. So now when you press the G key, you will see that this is making a lot more sense. Now go ahead and remove this grease pencil. So this means that when we switch to object mode and go to the object tab and enable the axis, when we press the R key to rotate this object, notice that the vertex follows with it. So now when you switch to edit mode and having this vertex selected, if you press the shift key down, having this on local, when you click change the X value, you'll notice that it's moving according to the internal coordinate system that belongs to the object. Of course, when we click on a global, press the shift key down, change the X value, now it's just simply moving along the global coordinate system. So here you could say that this is moving along world space. Then when we switch to local, the vertex is moving along an internal local space that belongs to this object. I want you to go ahead and do Alt R to reset the rotation. Now you already seen that, okay, so the vertex is going to be using an internal local coordinate system that belongs to this object. Now when we press the R key to rotate this object and do Shift A and add, let's say, arrows, press the S key to scale this down, press the G key to move it. When we click on this object, press the Shift key, click on this object, do Control P to create a parent-child relationship. The imaginary center from this 3D grid, when the parent-child relationship is established, is going to be handed off to the parent. So here we can just do Shift A and add arrows and press the S key to scale this down. Go ahead and click this object, press the Shift key, click on this one, do Control P. So now when we click on this object, do Alt R, you will notice that this object can only use its the local coordinate system that it got when the parent-child relationship was created. So when we click on this object and change its X value, it's working in local space. And the vertex is also working with local space, but it's an internal local space that belongs to this object. So this tells you that this object is not getting to use the internal local space that belongs to this object. The only way we can do that is simply move this object to the center and move this object to the center and then create the parent-child relationship. So go ahead and click this, do X and delete. Click on this object, do Alt G and Alt R to reset the rotation and location. Click on this object, go to the Object tab and remove that relationship. Now we're going to do Alt R and Alt G. Because everybody's in the center, when we click on this child object, press the Shift key down. Now find the parent, do Control P and create that relationship. Now go ahead and click on this object, press the G key, move it and rotate it. Now when you click on the child, press the G key, you'll notice that it's using basically the local coordinate system that is aligned to the object. But again, this object is not getting to use the internal local coordinate system that is being used by the vertex. We just manually did this. Okay, so it's going to work the same way, just like how the vertex is doing it. So this is how you can control the local space orientation and position based on how you create these parent-child relationships. Anyway, go ahead and click this, do X and delete. Click this object, do Alt R to reset its rotation. Now make sure you press the G key and just move this object over here. Okay, so now you understand this idea over here. So I'm just going to go under File, do Save As. Actually, let's go ahead and just save this file. Go ahead and switch to edit mode and click on this vertex. We're first going to look at how rotations work at their most fundamental level when we are using the coordinate system. So what I want you to do is first press the R key to attempt to rotate this vertex. You will see that it's not possible to rotate a single point on a coordinate system. This vertex is going to need another point of reference to rotate around. This is the only way you can rotate a vertex. So right click to cancel. So first press the G key and move this vertex with your mouse in a circular motion. So you can see that in order for this vertex to appear that it is rotating, we can only do this by changing its location on the X and Y coordinate system. Go ahead and move this vertex over here. Now press the E key to extrude out another vertex and place it over here. Now go ahead and click on this vertex. Now we can use this or tell this vertex to rotate around this vertex as a reference point. So first press the G key and attempt to do this manually. You'll notice that this gives us the ability to rotate this line. Basically all we're doing is again changing the X and Y location values of this vertex to make it appear that the line is rotating. But notice it's difficult to keep that offset maintained when we're doing this with the mouse. Now the other way we can rotate this is also click on this vertex and press the G key. We can rotate the line any way that we want. And again, we're going to have a difficult time maintaining that offset. Sometimes the line gets smaller or sometimes the line gets bigger. Okay, so go ahead and put this vertex over here and click this vertex over here. Now we're going to tell Blender to help us out. So here I want you to click on this vertex, press the Shift key down, click on this one. And right now you can see that the 3D manipulator is going to appear in the center. I'm going to zoom in over here. Now what I want you to do is to go ahead and switch this to active element. This simply throws the 3D manipulator to the last vertex that was selected, which appears white. Now when we press the G key, here both X and Y values of these vertices are changing. So this gives us the ability to move this line anywhere that we want. Now if we want to rotate this line, we can just press the R key. But notice that the outer vertex is simply changing its X and Y location values to make this line rotate correctly. Okay? Now what I want you to do is to go ahead and switch to median point. So now when we press the R key, we are rotating this line from its center. So the question is, how are these two vertices doing it? They of course are looking at a point of reference at the center over here, which is being represented by this 3D manipulator. So we can actually expose that by simply doing a W and do subdivide. Now you can see that we get a vertex. So now when we click on this vertex, press the Shift key down, click on this one, and press the R key to rotate, you can see that it's still doing the same thing. Both of these vertices are simply rotating around that reference point, meaning that they're simply changing their X and Y values on the coordinate system and maintaining that offset, giving us the illusion that this line is rotating. Now go ahead and click on this vertex, do X, and let's just dissolve that vertex. Now go ahead and click on this, press the Shift key down, click on this. So now you understand at the most fundamental level how two vertices are rotated. Okay? Now what I want you to do is press the E key to extrude and kind of like make it like a cube, press the A key to X and just delete only faces. Now we have 4 vertices over here. Now of course if we attempt to rotate this with our mouse, this is going to be difficult to do one vertex at a time because we have to maintain this shape. So here if we press the A key and press the R key to rotate, all 4 vertices are simply changing their location values on the X and Y coordinate system to make this shape appear as if it's rotating correctly. So how are they doing this? They're doing it the same way by looking at the center of the 3D manipulator. So we can expose this by doing Alt E and extruding on only vertices. Okay? Now right click to cancel. Now do Shift S and do cursor to selected. Do Shift S and do selection to cursor. So now you can see that if we select on all these 4 vertices and leave this unselected, press the R key, we're again maintain that offset and gives us the ability to keep this shape intact. Okay, now go ahead and click over here, press A, press C, click it, do X, and now just delete those vertices. Now let's take this to a much more complex level. Now what we're going to do is press the 1 key, press the E key to just extrude up. Over here, press the A key, do X, and delete only faces. Now we have a three-dimensional shape. Now in order to rotate this inside a 3D space, again it's going to be the same exact thing. Of course it's going to be next to impossible to do this with our mouse, one vertex at a time. But if we select all the vertices and now press the R key 2 times, you can see that all these vertices are simply changing their location values and making it look like that the object is actually rotating. Right? But these vertices don't know anything about each other. So how do they do this? It's the same thing. We can do Alt E and extrude only on the vertices. Over here, right click to cancel. Now we can just do Shift S, do cursor to selected, do Shift S and do selection to cursor. So now when you do the middle mouse button, you can see that each vertex is using this as a center point to rotate around. So now when we click on all of these for vertices, you'll notice that when we press the R key, it's the same thing. Okay, so that's how that works. So now the question is that, okay, well, how does it work when you switch to object mode? Right, when we press the R key 2 times, how do the vertices know to rotate? It's actually very simple. If we switch back to edit mode, actually let's switch back to object mode first, do Shift S, do cursor to selected, go to edit mode, do A to D select, press the C key, select all these vertices. Now we're going to do Shift S and do selection to cursor. You will see that all these vertices are going to draw a line to the origin. Okay, this is how they do it. So now when you switch to object mode, you will notice that this is how your three-dimensional object actually rotates around the origin point. Now go ahead and just reload this file, and I'll see you in the next lesson. Thank you.